Hi, and welcome back to our chemistry flipped classroom, where today we're going to talk about the periodic table of the elements. So this is a feature in pretty much every chemistry classroom around the world, and we're going to delve into it and learn a little bit about what's on it and what it can tell us. So the periodic table organizes the elements in a particular way, and that organization allows us to learn a lot about each element simply from its position on the periodic table. We can predict whether it's going to be reactive or unreactive. We can predict a lot about its physical and chemical properties, and we can even tell which elements it's likely to react with. So what's on the periodic table? So all the elements, 118 elements, 90 naturally occurring elements, and 28 man-made elements are found on the periodic table. They're organized by their atomic number, and the atomic number is usually found near the top of the square, different places on different periodic tables, but it's always going to be on there somewhere, and it's always going to be a whole number because that number is how many protons that element has. So in our example here, hydrogen has 1 proton, so it has atomic number 1. No two elements have the same atomic number because the number of protons is the identifying characteristic of an element. Now, depending on the periodic table, there's going to be different pieces of information. You're always going to find the atomic number. You're always going to find the symbol. You are usually going to find the average atomic mass. Sometimes it'll list the number of valence electrons, and sometimes it'll even tell us the state of matter at room temperature. So let's delve into a couple of those things that we find on the periodic table. The first one is atomic number. Atomic number refers to how many protons an atom of that element has. And as I've said, no two elements have the same number of protons. Atomic mass is usually the average atomic mass, which is the average weight of that atom. It's derived by averaging the masses of all the isotopes of that element, taking into account how abundant they are. Okay, and what is that measured in? That's measured in something called atomic mass units, or AMUs. 1 AMU is the mass of 1 proton. AMUs are tiny. There's 6.022 times 10 to the 23rd AMUs in 1 gram. And electrons are even smaller than that. So we have a lot of AMUs in a gram, but whenever we're talking about atomic mass, we are measuring it in atomic mass units. We will also sometimes see the number of valence electrons in the square. Valence electrons are the electrons in the outermost shell. They're the ones that are available for taking, giving, or sharing. They can be transferred or shared when atoms bond together. So there's 3 main categories on our periodic table. Those are metals, nonmetals, and metalloids. And if you look at your periodic table, you can see that the left-hand side, we have all of our metals, with the one exception of hydrogen. Hydrogen is at the very top of the first column in the periodic table, and it's a nonmetal. All the other nonmetals are to the right of what we call the stair step. So we're going to draw a line that looks like a stair step coming down through the periodic table. And those elements that touch that line are considered metalloids or semi-metals. And that means that they have some characteristics of metals and some characteristics of nonmetals. And depending on the situation, they may behave as one or the other. But it's really important that you remember that metals are on the left of the stair step, nonmetals on the right of the stair step, and metalloids on the stair step. So let's talk a little bit about some of the properties of those categories. So when we talk about metals, they're good conductors of heat, they're good conductors of electricity, they are shiny or lustrous, they're ductile, meaning that we can stretch them into thin wires, they're malleable, we can pound them into sheets, we can shape them into objects. And one chemical property of metals is that they generally react with water to cook, and we have corrosion or rust. So that's our metals. Let's skip to the other side, the right side of the stair step, and let's talk about non-metals. So generally speaking, everything that we said about a metal is not true of a non-metal. They're poor conductors of heat and electricity. They're not ductile. They're not malleable. They're brittle. They break easily. They tend to be dull. Many of them are gaseous. And then the metalloids. So they have properties of both metals and non-metals. They're solids. They can be shiny. They can be dull. They do conduct heat and electricity better than non-metals, but not as well as metals. And this is actually where we find a lot of our semiconductors, which are very important in computer chips. And they do tend to generally be ductile and malleable. Okay, so those are some of the characteristics. How is our periodic table organized? It's organized in two different ways, or two different groups. We can group them into families, which are the columns. The elements in the families have similar properties. So the ones above each other are considered families, and they have similar properties. They're also organized by periods, or those horizontal rows. Within a period, they do not have similar properties. Okay. Okay, so how did we get here? So let's talk just a little bit about the history of the periodic table. One of the early periodic tables, and the one that we generally say is the basis for a modern periodic table, was created by Dmitry Mendeleev in 1869. So he was grouping elements, as many chemists at the time were doing, by atomic mass. And as he did, he noticed that there was a repeating pattern. So we call that periodic when it's repeating, hence the name periodic table. And so he started setting up his periodic table in a way that grouped those repeating characteristics together. And he actually left blank spaces for places where he thought there should be elements based on their characteristics, but that had not yet been discovered. And so he organized them into a table. He organized them according to atomic mass. He noted this repeating pattern of valence numbers, which leads to characteristics. And he noticed that all the elements in a column had the same valence number. That's not the same thing as valence electrons. It's how many bonds an atom can make, and that they showed similar physical and chemical properties. So this is Mendeleev's table. Looks a little different from our table. It actually looks more similar if you turn it on its side. What's unique about Mendeleev's table is that he saw those repeating patterns and he left the spaces. He predicted what properties those undiscovered elements would have, and it turned out as we found them that they did fit that way. So quite a ways later, Henry Moseley, who's an English scientist, changed the arrangement of the periodic table. So by 1913, we've discovered the proton, and he organizes the periodic table by the atomic number, or the number of protons, and that is our modern arrangement of the periodic table. And that fixed a few of the problems that they found with Mendeleev's periodic table. So today our periodic table is arranged by atomic number and by properties. Those groups or families are our vertical columns. Our periods are by energy levels in horizontal rows. And then it's divided into metals on the left, non-metals on the stair step, and metalloids on the right. So let's take a quick look at our periodic table and talk about states of matter of the elements. So almost every metal is a solid, with one exception, and that's this one right here. Mercury is our only liquid at room temperature metal. And it's one of only two elements on the periodic table that is a liquid at room temperature. The other one is bromine. So we need to know those two. Bromine's a liquid at room temperature. Mercury's a liquid at room temperature. Now, the gaseous elements are hydrogen, all of the noble gases in this column, in the last column, and then nitrogen, oxygen, fluorine, and chlorine. That's it. There are not a lot of elements that are gaseous at room temperature. And then one other thing that we need to know is the elements that are diatomic, meaning that when we find them in nature, we find them in pairs. They are always bonded with either something else or one of themselves. And so when we write them, we always write them with a subscript 2 if it's by itself, not necessarily in a compound, but by itself. And that would be hydrogen, and then nitrogen, oxygen, fluorine, and all the halogens. And we'll learn a little trick in class for how to remember those. All right, that concludes our quick tour of the periodic table. As always, I look forward to hearing your questions, and I will see you in class.